好，欢迎welcome back， 欢迎大家重新回到主会场。那我们下午继续精彩。我们下午4个项目的分享都是 OCP 比较重点投入的。那第一个主题分享呢，我们再一次有请CTO Bill Carter 上台。Let's welcome back again, Bill Carter.
Thank you, thank you. You're going to have enough of me after the end of today. Hey, I'm going to talk about rack architectures, and actually have this next hour I have a couple of guest speakers that we're going to cover all 4 of the different rack architectures that are available today. But before we do that, I want to talk about how we got here. Where we've been on this journey, and so I want to go back and look at, where we were 100 years ago. Does anyone recognize this relay? This is actually a relay that was used in the early telegraph days to send signals down the wire. It was developed by, well, at least in the U.S., by America Telephone and Telegraph, now known as AT&T. And they stretched wires across America. There's probably an equivalent system here in China as well for long-term communication. They put a bunch of these in a rack for switching, and this is what the relay rack looked like in 1922. Because they had so many of these racks, they actually wrote a specification for it and duplicated that around the United States. And so in 1934, that became the first EIA 19-inch rack. So if you're deploying EIA 19-inch rack equipment today in your data center, you're using technology that's 90 years old. And it was because of that there was this initiative to improve on the rack designs. And that started back in the 2011-2012 timeframe. And we've had several of those rack designs evolved. We're going to talk about some of those today. And hopefully we can eventually move beyond that and get back to the point where we have a common rack design. It was the growth of cloud computing that drove that innovation to redesign that rack, to optimize it for scale and efficiency. So like I said, there's 4 different rack designs today. Project Olympus was a design that Microsoft did 3 or 4 years ago. They've contributed that to Open Compute. There's the Open 19 design that was done in parallel by the engineering team at LinkedIn. And I'm going to have Zaid come up and talk about the Open 19 design. We also had the very familiar ODCC Scorpio project that most of you are familiar with. And Richard's agreed to come speak on that project. And then finally, we're going to close up this session with Steve Mills. And Steve's going to come in and talk about what's happened with OpenRack. That's the OCP, the Facebook contribution to OCP. And there's been 3 generations, or actually I guess we're working on the 3rd generation of that today. And we're really trying to incorporate a lot of the learnings from these other projects into one, trying to bring everybody together. Earlier this morning I said we focused on our differences 8 years ago. Now we're trying to focus on our similarities and bring things back together. So unfortunately, the speaker for the Microsoft Project Olympus couldn't be here today, and so I'm going to try to cover those slides, so bear with me. So a little bit about Project Olympus. It is a complete rack design, designed for full rack deployment. There was several components of that were designed and shared and contributed to the community. The first is a rack. It's a 19-inch rack. So it uses the same rack architecture from the AT&T 1934 days. But there was modifications to it. The one modification is that they built a rack management solution across the back of that. So as these compute nodes would slide into the front, they'd automatically connect into the back, and you'd have an integrated rack management solution. They also incorporated a universal power cord so that regardless of the data center that it was going in, it would be able to connect into the data center power that was available. In many data centers, the actual power connector is a different shape, has different pins, different polarities, and so they designed a system that power cord was interchangeable. So at the day of deployment, they'd pick the right power cord, they'd plug it into the rack, and it would power up. At the same time, they also designed a different, on the back of the rack, it's actually a power distribution system. So it takes that power cord, converts the signals, the proper signals, to distribute AC power to all of the server nodes. Again, it's hot plugged in from the back. They had 1U, 2U, and 3U server chassis or storage chassis that were part of this design, and those are used interchangeably in this solution. And they designed a new power supply, and I'll talk about that in a minute. It was actually pretty unique power supply. Rather than having two power supplies mounted in the chassis, they have one supply, and inside that, they actually have two rectifiers. And so they're able to have that failover. They're able to provide power from two different utility feeds, and it was all captured in one silver box. So a couple of the features. One is they continue to have backwards compatibility with the 19-inch EIA 310 standard. Like Scorpio and like OpenRack, it's a 1,200 millimeter deep rack, so you can put plenty of IT equipment into it. They had a power solution that, again, was built onto the back, bolted onto the back. It did both power distribution and rack management, and it offered resiliency. That power supply that I talked about, it had two rectifiers in it, so you had two different utility feeds, but it also actually broke it out even further and had rectifiers on each of the three phases. The beauty of that is that you actually have phase balance. So in a three-phase utility feed, today, a lot of times we convert each of those phases and we produce a DC output or an AC output, and those AC outputs can become imbalanced. With a phase balance rectifier, you're actually able to have the exact same current loads on all three of those phases. All of that was built into this silver box, into the power supply that's in the Project Olympus. All of the compute nodes are hot pluggable, and they blind mate in from the front and mate into that power distribution, strip on the back. The other thing that they did is they obtained worldwide safety and certifications for all of the components. That was necessary because they install these into their own data centers around the world. But in some instances, they actually install this rack into a data center that's owned by one of their customers, or in a data center that we call a colo data center, so it's owned by somebody else. And in those cases, they may have different requirements for safety or FCC emissions, EMI emissions, and so they wanted to have worldwide certifications on all of this equipment so that it was compatible in any of their locations, regardless of whether it's a Microsoft data center or a customer data center. So that was a pretty unique, feature, as well as just all the scalability and ease of use of Project Olympus. In the lower left is a picture of one of their two-socket compute nodes, and again, you can see how it's very nice, open design, plenty of airflow through it. You'll notice that there's only one silver box in the corner back there. That's the power supply, and that resiliency and phase balance is all built into that single power supply. So that's Project Olympus. Now I'm going to invite a couple other folks to come back up, and we're going to start off with Zaid Ali Khan again, the Infrastructure Development Manager at LinkedIn. And I'm going to ask Zaid to come on up, and he can talk a little bit about the Open 19 architecture.
Thank you very much, Bill.
Uh-huh.
Thanks.